Hello and welcome to the lecture. Now, in the last lecture, we discussed that instead of passing data, now we can also pass functions as arguments, thus enabling function composition. Sometimes passing these functions as arguments is also called passing behaviors as arguments. And as promised, we will see a few examples in this lecture. Now, let me first give you a JavaScript example since I mentioned that Java was rather late to the functional programming game. So, the example here is I have an array and I just want the even numbers out of that array. So, this is a simple enough example, and we all know the traditional way of trying to do this. We can write a massive function, loop through the array, create a new array and store only the even elements in that array and then print them out. So let me try and run this, and it gives us the answer. It's not ideal. There are few undefined elements. I know you could optimize this. You do not need to create another array. You could have other ways, other small optimizations to do this, but you will still have to write the loop and get caught up in how to implement the loop, then extensively test the aspects of the loop in addition to the actual functionality. Let's say if the size of the array changes, then you need to worry about what do you add in here. At least think about it, right? And all of that involves lots and lots of work, and the code logic, what you are actually trying to do is a simple thing like get the even numbers out. But that true meaning of what you are trying to do is deeply buried in this for loop, and if your program has a lot of these functions with a lot of these loops and variables, it would take a lot of time for you or anyone else reading this program after a week to realize what is going on. So let's try and simplify this massive process with ceremonies now, shall we? Now let us try and run the same example in the functional programming way. So we still have the array that we had for the previous example. Now we have a small function isEven, and what does isEven do? The isEven just checks whether a number is even, returns true or false based on that. Simple enough. And now we pass the isEven function to the filter function, which is a higher order function. Now, why is filter a higher order function? Well, as I had mentioned, it is a higher order function because it accepts this function isEven as an argument. And then the sole purpose in life of this filter function is to create another array with the elements that pass the filtering criteria that we passed, in this case even numbers. So let us try and run this, and sure enough it gives us the right answers. These are the even numbers. Now notice that we haven't written any for loops or iterators. The code is much cleaner. Now, to be clear, the loop does exist in the filter function, but we don't need to worry about it since it has been tested billions of times because it has been used so extensively by everyone writing programs based off it. Now, higher order functions like filter, which again means functions that accept other functions as arguments, enable function composition, which means one function could accept a few other functions as arguments, and this way you could build massively complex programs by just composing small functions together. Just like we use Lego blocks and can create a lot of complex items out of these simple small Lego blocks. So your program is easier to read and just comprises of all these composed functions. Now, suppose our requirements change and we have to have both odd and even numbers separated out. Traditionally, we may copy the whole function and iterate again. But in this case, all we need to do is to write an isOdd function. You need to change the criteria and you need to pass the isOdd function now. If you want to print it, could do so here. And it gives you the odd numbers as well. Similarly, if the array size increases, you don't need to worry about anything in the program right now. It just works. You could give it anything and it would just work out of the box, both the odd and even. So hopefully now you are warming up to the functional programming paradigm, and now it also turns out that we can make this code even more concise. So let's see that in the next lecture. Now lastly, as always, if there are any questions about the content, please do let me know in the comments below. Also, if you would like me to cover any more programming topics, please also let me know in the comments below. And finally, since this is a new channel, if you like the video, please like, share and subscribe, and please click on the bell icon to be notified about future video uploads.